On the morning of July 3, 2025, under the clear skies of Kazakhstan's sprawling Baikonur Cosmodrome, a mission rooted in history, endurance, and silent utility began its ascent. At precisely 12:43 p.m. local time, 7:43 Greenwich Mean Time, a Soyuz 2.1A rocket thundered into the sky from Launch Complex 31-6, carrying aboard it the Progress MS-92 cargo spacecraft, known internationally as Progress 92, on a vital resupply mission to the International Space Station (ISS). It was a moment both routine and remarkable, marking the continuation of Russia's nearly half-century legacy of automated cargo missions that have served as the lifeblood of orbital stations from Salyut to Mir, and now to the ISS. Though it did not carry astronauts or scientific breakthroughs destined to make headlines, the cargo ship's journey encapsulates a quieter triumph: the sheer reliability and strategic importance of a vehicle that has helped sustain humanity's foothold in low Earth orbit. Only 9 minutes after launch, Progress 92 successfully separated from its launch vehicle and was inserted into a parking orbit approximately 200 kilometers above Earth. Almost immediately, the spacecraft deployed its power-generating solar arrays and navigation antennas, enabling its systems to stabilize and begin the methodical process of orbital phasing and alignment. Over the course of 34 carefully timed orbits spanning 2 days, the uncrewed vehicle will perform a complex ballet of engine burns to gradually raise its orbit and synchronize with the ISS. On July 5 at 9:48 Greenwich Mean Time, it is scheduled to dock autonomously to the rear port of the Zvezda service module on the Russian segment of the station using the Kurs rendezvous and docking system, an automated docking technology refined through decades of Russian spaceflight heritage. Onboard Progress 92 is more than just cargo. It carries 2,567 kilograms of critical supplies that touch nearly every aspect of station operations. Inside its pressurized compartment, there are 1,400 kilograms of dry cargo, which include an assortment of scientific equipment, maintenance tools, biomedical supplies, spare parts, personal care items, fresh food packages, clothing, hygiene kits, and even morale-boosting letters and tokens from Earth. In addition to daily essentials, these supplies enable dozens of ongoing microgravity experiments. Some involve protein crystal growth that may revolutionize pharmaceutical drug development, others involve the combustion properties of different materials in space, and still others are linked to long-term biological studies examining muscle atrophy, immune response, and vascular behavior in astronauts, knowledge that directly supports long-duration missions to the Moon and Mars. Crucially, the cargo manifest also includes 880 kilograms of propellant, which will be transferred to the station's thrusters and fuel tanks to support ISS orbital maintenance. As atmospheric drag slowly pulls the ISS down toward Earth, regular reboost maneuvers, often carried out by docked Progress or other propulsion-capable vehicles, are required to maintain a stable altitude of roughly 400 kilometers. This is especially vital in the face of an increasingly congested orbital environment, where maneuvers to avoid debris are becoming more frequent. In addition to the fuel, the spacecraft delivers 420 kilograms of fresh water and 40 kilograms of compressed nitrogen, the latter used to help maintain the breathable atmosphere aboard the station. In space, where every breath of air and drop of water is manufactured or delivered, logistics take on a life-or-death importance. This mission takes place during a period of geopolitical complexity, where earthbound tensions, particularly between Russia and Western nations, have tested the limits of international cooperation. And yet, in orbit, the collaboration endures. Despite diplomatic strains, the ISS remains a symbol of what's possible when nations prioritize shared goals over strategic rivalries. The station, crewed by a diverse international team representing NASA, ESA, JAXA, and Roscosmos, continues to operate smoothly with contributions from all sides. The Progress MS-92 launch, carried out efficiently and without incident, serves as a subtle yet powerful reaffirmation of Russia's commitment to its responsibilities aboard the ISS. The Progress spacecraft itself is an icon of dependable aerospace engineering. Since its debut in 1978 as a derivative of the crewed Soyuz capsule, the uncrewed Progress system has flown more than 170 missions, the majority of which were to Soviet and Russian space stations. Each evolution of the vehicle has introduced new enhancements, and the MS series represents the current pinnacle of that evolution. The MS variant features updated avionics, satellite-based navigation via the GLONASS system, improved docking cameras, more efficient solar arrays, enhanced micrometeoroid shielding, and redundant telemetry systems. While the spacecraft is capable of autonomous operations, it can also be remotely piloted by cosmonauts aboard the ISS or by ground controllers in Korolyov, offering multiple layers of redundancy for safety. Notably, the MS-92 vehicle will remain docked to the ISS for several months, during which it will assist with orbital adjustments and serve as a storage compartment for waste. Once its mission is complete, the spacecraft will be loaded with garbage, discarded equipment, and experiment remnants, after which it will undock and perform a controlled deorbit maneuver. It will then burn up in the Earth's atmosphere over the South Pacific Ocean, a designated spacecraft cemetery, bringing its mission to a fiery but essential conclusion. This end-of-mission ritual not only frees up valuable docking space but also helps manage the station's finite storage capabilities, contributing to operational hygiene in an environment where space, quite literally, is limited. Beyond the practical aspects, the continued use of Progress cargo ships offers insight into the strategic calculus of Russia's space policy. As Roscosmos pursues its next-generation ROS, Russian Orbital Service Station, planned for deployment in the late 2020s and explores lunar collaboration with China, its role in the ISS program remains both symbolic and substantive. The Progress MS-92 mission is not just a logistical exercise, it's a geopolitical signal that, despite shifts in global alliances and technological trends, Russia is still a crucial player in crewed spaceflight. Moreover, it demonstrates a form of space diplomacy, wherein even adversarial states find mutual interest in preserving scientific infrastructure that benefits humanity as a whole. This mission also comes amid broader conversations about the future of the ISS itself. With retirement expected sometime after 2030, space agencies and private companies are preparing for the next phase of low Earth orbit habitation. NASA has partnered with companies like Axiom Space and Voyager's Starlab to design commercial replacements, while ESA and JAXA are exploring modular contributions to future platforms. Yet, while eyes turn toward these next-generation stations, the current ISS, sustained by unsung missions like Progress 92, continues to deliver cutting-edge science, foster international cooperation, and inspire future generations. For the Expedition 72 crew aboard the ISS, the arrival of Progress 92 will bring not only equipment and sustenance but also a psychological boost. In the isolating void of space, where days blend into nights and Earth is a silent blue orb below, the arrival of a cargo vehicle is a moment of celebration. Crew members often gather to watch the final approach and docking on internal monitors, and the opening of the hatch is a symbolic reconnection to Earth. Each delivered item, from scientific tools to a fresh apple, is a tangible reminder that they are part of something larger, that the people of Earth continue to support their extraordinary mission. As the Progress MS-92 spacecraft silently glides through its carefully calculated path above our planet, its mission, like those of its many predecessors, will likely pass with little public fanfare. But make no mistake, without these lifelines, the great adventure of human spaceflight would stall. No grand discoveries, no awe-inspiring images from space, no extended presence in orbit would be possible without the tireless efforts of logistical missions like this one. Thus, on July 3, 2025, as Progress 92 soared through the stratosphere and settled into orbit, it reaffirmed an unbroken chain stretching across decades, continents, and ideologies. It reminded us that behind every giant leap are thousands of small, steady steps, and Progress 92 is one of them. Reliable, routine, and indispensable. It is, in its own quiet way, the unsung hero of humanity's presence among the stars.